Alright, so we're going to start with some direct variation. So this is going back to the linear chapter in our textbook. So direct variation is basically where x and y are related directly to each other through a constant, and sometimes it's y equals a times x, or y equals kx, or y equals mx, as in mx plus b. So I've seen all three of these letters used, but it's really all the same thing. It would just be like we have y equals 2x. So every x, you just double it and you get your y. So there's this very direct relationship. There's no y-intercept. The y-intercept is, sorry, there's a y-intercept. It doesn't show up in the equation because it is 0. So, when we talk about this in words, we'll say y varies directly with x. That's the way it will be worded. And then a or m or k is the constant of variation. And we're starting with this concept with something that's more familiar, and then we're going to apply it to new types of equations later. Alright. So let's say they give us a point. So here's an example. They give us a point, -3, 2. And they tell us to write a direct variation equation that goes through this point. So if we know that y equals a times x, and I know that these are my x and y values on this line, then I can simply divide and I get a equals -2/3. So y equals -2/3 x is my direct variation equation. If you're good with formulas, you can remember, like, the shortcut for this is a is always equal to y divided by x, but I mean, you really don't need to memorize that because this is so easy to remember. And then you just do that one step to solve. So let's look at the practice problems. I'm just going to go through and do a couple of practice problems from your worksheet. So number 4, it says x and y vary directly. Find an equation that relates x and y, then find y when x equals 3. So y when x equals 3. I'm going to bookmark that for later. So for number 4, they tell us that x equals 6 and y equals -8. So again, we're going to use our equation y equals ax. -8 equals 8 times 6. So -8/6 equals a. So -4/3 equals a. So now I'm going to write my equation. Y equals -4/3 x. There's part 1. And then my second thing I have to do is substitute 3 in for x to find y. So y equals -4/3 times 3. That divides, so we've got y equals -4. So there's my part 2. For the next set of questions, it's asking to tell if an equation is direct variation. And you can tell that by whether or not it's in this form, or whether it could be written in that form. So if you could write it or rewrite it as y equals a times x, or y equals a number times x, then it is in fact direct variation. If there's another constant hanging out, it's not direct variation. So for instance, number 14, y plus 2 equals 8x. This 2 right here shouldn't be there, so it's a no, not direct variation. So again, I'm looking at 19 and 20 with the tables. If it's direct variation, then it's in this form, and we know then that it goes through the point 0, 0. So that's the two things you're looking for, is does it have a constant slope? Is it adding the same amount each time? And does it go through the point 0, 0? So let's turn the page real fast. Still wet from when I cleaned it. Okay, so let's do number 20. X, y, -3, -1, 1, 3, 5, and -2, -2/3, +2/3, 2, and 10/3. Okay, so I'm going to think about this. I'm going to pick a couple points. So if I pick this point, -2 equals a times -3. So if I solve this, a equals 2/3. Okay, now I'm going to pick another couple points. I'm going to pick this one, y equals ax. So 2/3 equals a times 1. A equals 2/3. Great. So we're just kind of making sure that it follows that pattern, that it's always adding 2/3. And then the other thing we want to know, does it go through 0? So if we're adding 2/3 each time, if I go from here, plus 2/3 is 0 at 0, plus 2/3, yes. So this is a yes. This is in fact direct variation.